So now we're going to talk about DynamoDB throughput. It is a huge question at the exam. They may ask you to compute some throughput, so pay attention and you'll have to remember a few formulas. So in DynamoDB, the particularity of it is that you have to provision a read and a write capacity units. So it doesn't auto-scale like Ernest Lambda does, where it's just all magical. In DynamoDB, you have to say how much throughput you want for your tables, and that's a design choice. So there's the read capacity unit, or RCU, which is the throughput for reads, and the write capacity unit, WCU, for the writes throughput. And so you're able to independently scale the read capacity units from the write capacity units. So if your application is read heavy, maybe you want more RCU. If it's write heavy, maybe you want more WCU. Now you also have the option to set up auto scaling of throughput to meet the demand, and that's quite important. And the throughput can be exceeded temporarily. So for example, if you do a little bit more reads, a little bit more writes than what you're allowed to, DynamoDB will allow you and you'll just use some burst credits. But if you use over the burst credits, so if the burst credits are empty because you overused your RCU or WCU, you'll get a provision throughput exception. And then it's super advised to do something called an exponential backoff retry. So let's do a deep dive into WCU or write capacity units. One write capacity unit represents one write per second for an item up to 1 kilobyte in size. So you'll have to remember that idea. It is actually the most simple for WCU. One WCU represents one write per second for an item up to 1 kilobyte in size. If you go over 1 kilobyte, then more WCUs are consumed. Let's go through examples because these are the easiest way to remember, and these examples may be asked at the exam, and so you need to understand how to compute the WCU. So say we write 10 objects per second, and each object is 2 kilobytes each. Well, just compute it in your head if you want to, or pause this video. But we're going to need 2 times 10 equals 20 WCU. So why? Because we write 10 objects per second, so 10, and then the objects are 2 kilobytes each, and 1 WCU represents 1 kilobyte, so 2 times 10 equals 20 WCU. Okay, let's look at other ways. If we write 6 objects per second and each of them is 4.5 kilobyte each, now look above. Well, because it is 4.5 kilobytes, you're going to do 6 times 5. And so the 4.5 gets rounded to the upper kilobytes for WCU. So it doesn't give you less WCU because you have a slightly smaller element than 5 kilobytes. So it will automatically get rounded to the upper kilobytes. And so here we have 6 times 5, which is equal to 30 write capacity units. Now, if we write 120 objects per minute, and they're 2 kilobyte each, here you have to pay attention. It's not per second anymore, it's per minute. So you'll have to divide 120 per 60 to get the throughput per second times the number of kilobytes, which is 4 WCU. So it's super important for you to understand this formula and practice a little bit. Now let's talk about reads, because the writes are very, very simple. First, in DynamoDB, you get the option to choose between strongly consistent read and eventually consistent read. So eventually consistent read is that if you read just after you write something, it's possible you'll get an unexpected response because of the replication. So that means that you may get an old data or you may get no data based on what the row was before. Eventually consistent means that if you keep on asking, eventually you'll get the right results. And eventually probably means a few hundreds millisecond, right? Or there's something called strongly consistent read, which is if we read data just after a write, we will get the correct response, the correct data. And by default, DynamoDB will use eventually consistent reads for get item, query, and scan. But there is a consistent read option parameter that you can set to true, and if you do so, you will get a strongly consistent read. Now you may ask me, why would we not choose strongly consistent read all the time? Well, because there is going to be an impact to your RCU. We'll see this in the next slide. But first, an example. So we have our application, and DynamoDB, as I said, is going to be replicated across 3 AZ. So this is a very simplification, but we have a distributed DynamoDB system with 3 servers, and it's a bit of a mystery how DynamoDB works, but for example, I'm just going to give you an illustrative point to explain the strongly consistent reads and the eventually consistent reads. So our application will do a write to the DynamoDB, and maybe it will reach the first server. And the first server says, okay, I got it, all fine, the write is correct. What will happen in the background is that the data will be replicated to the server 2 of DynamoDB and also replicate it to the server 3 of DynamoDB. Now this replication may get time. And so if you read right after writing and you read before the replication has happened or it's fully complete, then you are in the eventual consistent read pattern. And here, for example, we read from server 3. We don't know where we read from. It's just, again, illustrative. But so if the reads happen before the replication, we'll get eventually consistent read. But if we ask for a strongly consistent read, then the read will just be a little bit longer, but we'll get strongly consistent read. And so we see how when we have a distributed system, we have two kind of scenarios that can happen. So why am I bothering you with strongly and eventually consistent reads? Well, because it impacts RCUs. So one read capacity unit represents one strongly consistent read per second or two eventually consistent read per second for an item up to 4 kilobyte in size. So this formula is a little bit trickier because now there is 4 kilobyte in size for the items, and also there's going to be a strong difference between strongly consistent and eventually consistent. And if the items are larger than 4 kilobytes, more RCU are consumed. So let's take an example. Say we want to have 10 strongly consistent reads per second of 4 kilobyte each. That's actually the easier case. So we need 10 times 4 divided by 4 equals 10 RCU. So why? Because we want 10 strongly consistent reads per second, which is a definition. 1 RCU equals 1 consistent read per second. And then each item is 4 kilobytes each, which represents the definition. And so we divide 4 kilobyte divided by 4 kilobyte. That gives us 1. 10 times 1 equals 10. Another example, say we want 16 eventually consistent reads per second, and each of these read is going to be this time 12 kilobytes each. Well, we need 16 divided by 2 because one read capacity unit gives you 2 eventually consistent reads per second, times 12 divided by 4. Why? Because each read gives you 4 kilobyte in size, and we have 12 kilobyte elements, so we're going to need 12 divided by 4 equals 3 for each read. And so if you do the math, we'll get 24 RCU. Finally, if you ask for 10 strongly consistent reads per second and each of them is 6 kilobyte each, then we're going to need 10 times 8 divided by 4 equals 20 RCU. And why? Well, because we have to round up this 6 kilobytes all the way up to 8 kilobytes because it doesn't do intermediate in size. It goes by increments of 4 kilobytes. And so you have to absolutely remember all these formula, and this is the most complicated, and this is going to be asked at the exam for sure. So very important for you to understand. Finally, just a little note on internal partitions. The data is going to be divided internally into different partitions, going to be distributed, and the partition key goes through a hashing algorithm to know which partition data goes to. And then if you want to compute the number of partitions, I think this is quite advanced and not asked at the exam, but you get a capacity where you take the total RCU and total WCU, you apply this formula, and then you get the size of your data set, you divide by 10 gigabytes, and to get the total number of partitions, you do the max of these two numbers. And so that's a little bit more complicated, obviously, but it's good to know. And I don't think this is asked at the exam, so don't remember this formula necessarily. But what you should know is that the WCU and RCU, they will be spread evenly between partitions. So if you have 10 partitions and you have 100 WCU and 100 RCU, then each partition gets 10. And that's very common misconception. Now, finally, throttling. If you exceed your RCU or WCU per partition, then you get a provision throughput exceeded exception. And the reason may be that you have a hotkey, so one partition key is being read too many times. For example, you're selling some stuff on a store and this is a very popular item, and you can get hot partitions and also very large items. So if, for example, if you get a 400 kilobyte item, then you need to assign more RCU or more WCU. Solutions for these are exponential backoff when you get an exception, which is already included in the SDK if you use an SDK. And you need to distribute your partition key as much as possible. And finally, if it's an RCU issue, we'll see this in the future lecture, but we can use DynamoDB accelerator called DAX, and it's basically a cache. So that's it for throughput, throttling, RCU, WCU. I hope that was helpful, and I will see you in the next lecture.